So now we are maybe interested in how to recreate this iteration steps into Erdas or in Erdas Imagine. Therefore, we will need our layer stack. As you can see here, this is Berlin, and we will need the classifier, therefore, and especially the unsupervised classification module. So just open this, and this is called ISO data, which is quite similar to k-means, but normally you're using ISO data to find the correct answer towards the number of clusters. So this is more or less k-means. So oh, that was a little bit fast. So you will need 3 files. First, the input raster file, which is probably the layer stack, because you need a lot of information to gain a good resulting classification result. Then you will create some kind of thematic raster, which is the output cluster layer, which contains the class number per pixel. So every pixel has then an indicator which means, okay, this pixel belongs to class number 5 or class number 10 or whatever. So we will use the name unsuper 14 Berlin 2001 to indicate which what I have done. So I've done an unsupervised classification with 14 classes containing the image of Berlin in the year 2001. And therefore we will also create a signature file. So unsuper 14 Berlin 2001. The name can be different, but I think this name is quite sufficient for our task now. And as you can see, I've chosen the number of classes 14. Why is that so? Because normally if you're doing that kind of classification, then you should start with a bigger number of classes, because you can always merge down or merge together 2 or 3 different classes to one class. But if you will start with 2 or 3 classes, then to separate these classes into subclasses is quite, or is much more it's much harder than just merging down 2 classes to one class. Therefore we will start with 14 classes, not so much classes, because a lot of more classes will serve a lot more working time to merge down all the classes. So 14, I think this will fit our needs now in the moment. And next thing to specify is the processing options. Therefore we will find value for maximum iterations. So how many iterations can be done using this program in the end to reach a certain goal, and the goal to reach is the convergence threshold. This means how many percent of the pixels can change their class belongings in each iteration step. In the moment, this is set to 95% of the pixels should not change the classes in an iteration step. We will increase that value to 79.5%. So in the last iteration step, this step which will be done, 2.5% of the pixel will or can change the classes. We will leave the classify zeros blank, because our zeros are non-existing objects, and this is it for the moment. We'll start with the classification, and as you can see here, the convergence is increasing to 84, 48, 69, 79%. Now we are done with the signatures, and the signatures are containing the centroids and their values regarding the 6 bands. So now we are done. We have done our classification, and now let's check whether this was fine just by opening this raster options. Make sure not to check the clear display button. Okay, we're now done. This is a classification approach, and we would just zoom in into the area of Spandau in the western part, and as you can see, you have the water areas over here. So therefore blend and swipe. So just to check whether our objects are classified correctly. So you will have the water class over here, or the water body over here, and this is it has a special number in this case. I think just to make sure to identify this, we will use the inquire cursor, and navigate this to the water, and as you can see, the pixel value is number 1, so it indicates it's class number 1. Once again, this is a thematic raster, so you will find some attributes for that. And as you can see, the row number is the class number, and we can check this to be class number 1 and marked in blue. So what is now done is that you have changed the color of this class. You can also make this complete or you can decrease the opacity to 0 to just to have a look beneath the class, so you can see that this is all water, and this is fine for now. So once again, attributes. Oh, I've already opened this. Where's the attributes? Well, here, attribute editor. Go back there, say this is 1, and we will use the bluish color to indicate. So what is this here? What is this? So this is class number 8, but we are interested in this. Yeah, this pixel number, or the pixel value is 2, so the class number is 2. Once again, go to the attribute area, class number 2, mark it in dark green, and you will probably find your forested areas over here. So you can also change the name of the class. So it's class number 1. We can make it to contain the water body. It's probably water body like this. And this is forest. So in the end, you will maybe come up with the ideas of that this is agricultural field, class number 12. This is agricultural field, class number 13. And class number 14 is maybe the same agricultural field. So 12, 13, and 14 are all agricultural fields. Therefore, one probability or one possibility to indicate this in your mapping is to change the class values to the same color here, marked maybe in orange. So this is indicating that every open ground field, like maybe an agricultural field, is marked in this brownish or orange stuff, orange color here. But as you can see, you will find a lot of objects that are in the same class, like this hangar here from the airport Tempelhof, which is probably not an agricultural field. But the main problem in using unsupervised classification is that you're not classifying objects in their physical meaning, but you're classifying objects in their spectral behavior. And maybe an open grounded or an open ground field has the same spectral reflectance like this kind of concrete building. Yeah, and so therefore you have to be very careful in using that kind of classification approach. But as you can see, the water body is nearly totally accurate. Maybe there are some problems over here, but just think about shadow. What does shadow mean? Shadow means that you won't see light, or light cannot reach this region. And as the ETM sensor is measuring the energy which is reflected, when there is no energy reflected, or when there is no sunlight reflected, then you won't find any high values in the sensor. And this indicating you, or the other way around, is that you will measure low values. And also water is sending out low values because it's absorbing everything. So normally you will find water bodies and areas of shadow in the same class. But just by using blend and swipe, you can probably say, okay, you will have some kind of qualitative way to indicating, okay, my classification approach was quite successful. This is one way to look at this. But another way is to change or to have a look on the reflectance values itself.